Strings. You know, what's very characteristic and really fundamental of any programming language is the ability to work with quote-unquote strings of characters. In other words, just character data. So the difference is how Java deals with character data versus other programming languages. C Sharp, VB.NET, VBScript, JScript, JavaScript, all of the the hot topic kind of programming languages allow you to deal with string data or character data. Even XML has a special way of dealing with C data or character data. Now, what I want to start off first doing is define strings for you and let you understand and start laying out for you what a string is in the world of Java, because it's a little bit different in Java than it is in other languages. Then I'm going to show you how to create and start working with strings. And if you're really serious about Java, which you obviously are, you're going to hear a key word called immutability. If you look at the root, or not the root of it, but a part of it, I should say, you see mutability or maybe mutate in there. So immutability. We'll talk a little bit more about that as I explain the features of Java strings. Now, once we have the basics of creating strings and understanding how strings work, then I'm going to give you some handy methods or behaviors that strings have in Java. Then what I'm going to do, the last part of it, is I'm going to introduce you to another class called the StringBuffer class. So let's go ahead and jump right into starting to work with strings. To begin, I'd like to just start with a pretty basic class. And let's create a class called public class string demo1. And I'm going to use this class to kind of define for you what a string is, as well as how to start to build and use them. So public static void main string, that's an array of strings called args. So you've kind of seen strings in action a little bit already, and now we're going to build off of that. So I'm going to save that, and I'll save that in my C Java strings directory, and we'll call this string demo1.java. String demo1.java. And you know what? Let's just compile it to make sure we've got the name correct and everything is working. All right. We've already taken a look at how we can declare and work with several variables. Like we can create a variable of integer. Int my age. Okay, and I'll put equals 33. Or Boolean is funny, and I'll put true. I could create various different types of variables. Remember, there are 8 primitive data types that we've taken a look at, and they're mostly numeric. But what if I have some kind of information like Jenny? I want to store the name Jenny. Or I want to store something like employee. Notice how I'm putting that around quotes? Well, that would be an example of a string. String is any set of characters, A, B, C, D, E, F, G, inside of quotes. And because they're inside of quotes, they are considered to be what's called literal. That means that this set of string of characters is literally this set of string of characters. So it's locked down. So if I were to put a space in there, or maybe like a dash, that would all be part of the string, the space and the dash. It's part of what it means that it's a literal set of string characters. Now, a string, believe it or not, is very powerful in Java because each one of the characters in a string is actually represented by a single 16-bit Unicode character. And Unicode is a lot larger than ASCII characters. Unicode characters are 16 bits as opposed to the 7 or 8-bit ASCII characters. And as such, Unicode characters give us the ability to have international characters like Chinese characters or Hebrew letters or things like that. So Java strings are extremely powerful in that they're Unicode characters as opposed to ASCII characters. If you haven't already known this, let me kind of let you in on a secret about Java. Java is a full-featured object-oriented programming language. And in a few more titles from now, you're going to be spending a lot of time with me understanding just exactly what objects are and what does it mean to be object-oriented. But I want to kind of give you a sneak preview as to what objects are. And the way we're going to do that is by talking about strings, because in Java that is, strings are actually objects. And as such, we use a special operator called the new operator to quote unquote instantiate a string. So I could go ahead and create a string like this. String my string equals a new string. Okay? And that allows me to create a string. And then to assign the string a value, I could say my string equals hi, everybody. And then I can go ahead and put it to standard output, system.out.println, my string. Okay, so let's go ahead and compile that, and we'll run it. So it's very important to understand that strings are not just any ordinary type of variable. Strings are objects in Java, and you're going to see how that starts to play out. So here I created on line number 6, I instantiated a string. Now, on line number 6, I didn't give it an initial value, so it's null or just pretty much empty at that point. As a matter of fact, I'll go through and I'll show you what happens if I print it out. On line number 7 here, I went ahead and gave it a value. And then on line number 9, I'm using it and I'm calling the value. So you could see it saying, hi, everybody. What I'm going to do is I'm going to comment that line out. And I'm going to use the single line comments, and I'm going to go ahead and compile it. Now, something is going to happen that's interesting because I'm operating inside of the main method. Let's go ahead and compile it, and now let's go ahead and run it. So I'll say run Java application. And you could see nothing is happening. There is a little bit of space there, but it's an empty string. It's basically null, nada. All right? So that's how we go ahead and create strings. Now, there's another way I can create a string as well. There's about 3 different ways. That's method number 1. Let's do method number 2. So let's call the string 1, my string 1, my string 1. Okay. Now what I'm going to do is I'll create a string, my string 2. String my string 2 equals a new string, and I'll say CBT nuggets rock, which I do think that. All right, let's go ahead and do a system dot out dot println my string 2. All right, let's compile it. I'm going to get a little fancy on you. See this? Tools, compile is control 1, run is control 2. And after a while, you get really quick on this. You'll just be like control 1, control 2. So I'm going to start using the key control 1, control 2. All right, so here we can see that I went ahead and I created my string 2. And I'm using CBT nuggets rocks inside of the parentheses surrounded by quotes. Notice the space is included, even in the hi everybody example, in my string 1. Notice I have the comma space and then the capital E, comma space capital E. Here in the CBT nuggets rocks example, I also have a space. Okay, so that's the the second way I can count. Trust me, and if not, I'll write a Java application to count for me. All right, here's the third way. String my string 3 equals I love CBT nuggets. Okay, and I'll put a semicolon there. Then I'll come down here and I will do a system.out.println my string 3. Control 1, compile that up, and then we'll do a control 2. So control 2. And here you can see shortly here that I am still printing out a string. So on line number 11 here, I am also creating a string. So there are various ways of creating strings. And later on, as we start going through the course, you'll see I'll use different methods depending on the different scenarios. And of course, I'll go ahead and point that out. Now what I want to kind of get into is something about the fact that strings are immutable. That's something you're going to hear a lot about in the Java world. In the Java world, strings are immutable. As a matter of fact, as you get into .NET, you'll see some familiarities there too, but let's focus on Java. In the Java world, strings are immutable. Now, you might see, and I hate to bring you back to your horrific days of grammar and word derivation, but let's just take a look at the word immutable. I-M-M-U-T-A-B-L-E. I think that's how you spell it, immutable. And what I want you to see is you have mute, kind of like for mutate, and im for not, right? In other words, strings cannot mutate. They cannot change their value. Once you have created a string and given it a value, that value is unable to change. And you could think of it as just captured and frozen solid as it's in ice, okay? Now, here's the interesting thing. If you remember, strings are objects, and the string object is immutable, but the referencing variable is not. So let me kind of introduce you to some of the weirdness and some of the cool features that you get involved with when working with objects in Java, especially string objects. All right. The good news about this stuff here, folks, is just so you know, is if you plan on taking the Java programming exam, the Java programmers exam, you don't need to know about strings to the detail that I'm kind of showing you, but this is kind of real world because you'll be programming with strings a lot, so it's good to understand how they work. I'm going to create a string called S1, and I am going to assign that the value of CBT nuggets. And I'm going to put even a space in there, okay? And I'm going to do a system.out.println of S1. Let's print the value of S1. I'm going to do a control 1 and a control 2, and I'm thinking nobody is pretty surprised by what just happened. All right, now let's start having some fun. String S2 equals S1. Now, an interesting thing is going to start to happen here because, believe it or not, what I did was I created a second reference variable that is referring to the same string. You see, strings in any programming language can take up a lot of memory, and you're going to use them a lot. So what Java does, what the Java virtual machine does, is it creates a pool of strings, if you will, to go ahead and manage memory a lot better. So object speaking, S2 and S1 are basically pointing to the same thing. So if I change this to an S2 and I compile it and then I run it, I don't think there are any surprises there. Now, you have to understand there is an interesting thing happening in memory. All right, so now what I'm going to do is I'm going to change this back to S1, okay? Change that back to S1. And let's go ahead, and I'm going to come down here, and I'm going to say S1 equals S1.concatenate, concat, which is a method of the string object, which allows me to append information to it, or more text, and I'm going to say rocks. All right, let's compile this and run it. And you can see that I've got Java rocks. Now, what's very interesting here, is that what happens underneath the hood, because strings are immutable, and I said their value cannot change, what happens is S1 now is pointing to a new object in the memory heap. That S1, although the code looks like it's the same, it's actually not underneath the hood. All right, now what I'd like to do is take a look at some handy methods of the string class. Now, what is a method? You might be hearing this term for the first time. It's certainly one of the first times I'm mentioning it. A method is a behavior that is connected to an object. Objects have behaviors. Methods do things, okay? Attributes, as we'll learn here in a little while, describe the objects. They're like properties. All right, so let's start out by creating a string. So string S1, and I'll say it's CBTNUGGETS rocks. All right, and a good little handy method is called the char at method. And basically what it does is it allows me to find a specific character in a string and tells me where it is. So system.out.println, and I want to go ahead and print out s1 dot char at position 0, 1, 2. So let's take the fourth position. What character is at the fourth position? So let's go ahead and compile it, and we'll run it, and it is U. Okay, so look at 1, 2, 3, 4. Wait a minute. At the fourth position is an N, not a U. One thing you have to get used to here in Java is that everything in Java is zero-based. So it doesn't start with 1, it starts with 0. 0, 1, 2, 3, 4. So the character at position 4 in string S1 is U. A very frequent thing that you'll want to do in Java is compare the values of two strings to see if they're the same. So let me take a string S1 and let's call that fun, F-U-N-N, or all right, so I can't spell fun. String S2, and that equals fun in all caps. And what I want to do is I want to know if the string argument is the same as the other string, basically regardless of the case. Okay, I want to know if they're equal, ignoring the case. And if they're equal, print true. If they're not, print false. So let's do this. System.out.println, and I'm going to say, does S1 dot equals ignore case, and I'm going to examine string S2. Okay, so I will compile that, and I forgot my little semicolon there at fun, so we'll try again. Compile it, and I'll run it, and you can see it is true. Irregardless of case, S1 and S2 are the same. Now watch this. If I go ahead and change this to my horrible misspelling of the word fun and add another N in it and compile and run it, now you can see it is false. Okay, the value is not the same regardless of case. Something else that's extremely common to do, which you might be finding yourself doing pretty frequently, is determining the length of a string. So let me create a string, a long one. String S1 is CBT nuggets is the best training in the world. And I'm not just saying that because I do it. I think it's very good training. System.out.println S1.length. The length method of the string class returns an integer to me, and that integer tells me exactly how long it is. This string is 45 characters long, and yes, the spaces count. Now, when you are counting the length, it is not zero-based. Let me show you. Let's create a string. Let's just change this to 1, 2, 3, 4. Okay? So I will compile that, and I will run that, and you can see we have the length of 4. I know it can be a little bit confusing, but it makes sense. Hey, if you're going to find out how long something is, the first position in the string is 1, right? The first position in the string is 1, and so on. Two other handy methods allow you to jimmy the case of your strings. So if I do a string s1 and I say Java rocks, and I do a system.out.println s1.to uppercase and system.out.println s1.to lowercase, guess what's going to happen? Hey, if you figured that out, Java's pretty straightforward and easy. And you know what? I think after a while, you will start to see that is the case. Let's see what kind of mayhem we got ourselves into here. Let me line that up if I can. All right, so what do? I created a string s1, Java rocks. It's in various cases, uppercase J, all lowercase here, uppercase R, all lowercase here. What I did here is I did a 2 uppercase, put it all in upper, and I did a 2 lowercase. Let me just give you kind of a real world kind of a comment here. When you take in somebody's password, let's say, you see Java is a case-sensitive programming language. And if you're taking input and you just want to kind of simplify your life and you want to compare the values of strings, it's very common just to make everything uppercase or everything lowercase because that allows people to input information in any kind of case they want. And if you're not interested in the case of something, let's say you're creating an application where the password is not case sensitive, just make everything uppercase or make everything lowercase. A good question that comes up at about now is, how in the world do you know all the methods of the string class? How am I going to remember all that stuff? Well, let's start by examining a very, very critical website, java.sun.com. This website is going to have to become your best friend as a Java developer. Let's go ahead and start taking a look at the documentation. So I'm going to go to reference section here over the side, and I'm going to click documentation. And I want the Java 2 standard platform, because that's what we're using right now, is the standard platform. And I'm going to come down here, and I'm going to look for the standard edition documentation. And we're using 1.4.2 for right now. So we can look at the solution developer kits or the API documentation, and that's what we want. So I'm going to say view in English, unless you want to see what it looks like in Japanese, which would be pretty interesting, I guess. I've never looked at it in all the years I've been looking at this website. This website is gargantuan. It's huge. It's everything and anything you need to know about Java. Let's use the string class that we've been working with to go ahead and kind of familiarize yourself with this website. Now, Java has thousands and thousands and thousands of classes. We're going to be going over them. As a matter of fact, this is the first real class that we're talking about, and the array class, which we talked a little bit about earlier. Now, imagine you had a file system like your hard drive, C:, right? And you had thousands and thousands and thousands of files. Would you put them all at C:, barring the fact that there's a limitation of how many files you could have at root? The reality is you would not put all of your files at the root of a particular drive letter. What you would do is you would organize your files into folders. And Sun Microsystems takes the same concept here. And what they do is they organize their classes into what are called packages. And the most critical, most fundamental package to Java is java.lang. The java.lang package contains the fundamental core functionality of Java. As a matter of fact, the Java compiler automatically makes a reference to java.lang package without you having to manually do that. You can see that we've talked about primitive data types like Boolean, byte, character, double, float, integer, long. Well, those all reference classes in the java.lang package. Let's kind of scroll down here and take a look for our string class. I'm going to click string, and here we could see some information about strings. We can see that it is java.lang. The class is called string, and it's public final class string. Final here means you can't inherit from it. Inheritance in classes, what's that? We'll talk about that here shortly. Let's scroll down. Okay, you can read a little bit about the strings and a lot of good information here. And here you can see constructors. Constructors are special methods that have the same name as the class that you use to instantiate an instance of that class. You saw me use the string method here, okay? Or the string constructor rather. Let me scroll down a little bit and let's take a look at methods. For example, you saw me use char at or character at, and you have to put in an index. Remember I used character at and I put number 4 in there? It takes an integer of an index position in your string. You saw me use string, the concat. Now this is what's interesting. Remember when I told you that when you concatenate a string, it actually creates a new string? You see all this information along this column? This is the return of the method, what the method kind of kicks out. Character at returns a character, so when a data type of char. So when I did character at 4 and it said u, it returned u of type char. When I concatenated my string with another string, it returned a completely new string. Another method we used was equals ignore case, which return true or false. Okay, so you could come through here and you could play with a ton of these methods. They're really good, and during the course I'm sure we'll be taking a look at other ones. Here's the length method, which returns an int. Okay, let's take a look at what to upper and to lower returns. When we look at that, to lowercase returns a string altogether. To uppercase returns a string. Okay. Now, using strings, as I said, they're immutable. Strings don't change their value. And if you start messing around with the string methods that you just saw here, you're going to start creating a lot of string objects. And then once you start manipulating those string objects, you're going to have a ton of what are called abandoned string objects in your string pool. And that's just not okay, because that could really potentially cause some lag in your application's performance. So what we have is we have the StringBuffer class. The StringBuffer class should be used if you're going to be modifying your same strings over and over again. So let's go ahead and take a look at some examples on how to use the StringBuffer class. The StringBuffer class is really similar to the string class, except that one, you create a string buffer when you are creating your StringBuffer object, and 2, it's immutable. So I'll go ahead and create a string buffer, new string buffer, and we'll say CBT nuggets. Okay, and I've got a string buffer. And let's just kind of do a system.out.println SB. So let's take a look at what that does for us. So I'll compile that, and we'll go ahead and run that. Okay, and you can see CBT nuggets. Probably not, too much of a surprise there. But now what I can do is I can go ahead and say sb.append, and I'll do a space rocks. Okay, now yes, the string class had an append method, but it returned to me an entirely new string, reference, a reference to a new variable in memory. Here, what's happening with the string buffer is something a little bit different. And I'll show you that here, because what I want to do is kind of go out to the documentation, and let's take a look at the string buffer class, and you can read it. Here's the constructors for it. And we have append, and this takes the information and in itself returns a new string buffer. And you can append booleans, characters, an array of characters. You can specify an offset. I mean, look at all the things that you can append. You can see by the methods alone in the StringBuffer class that it is built for mutation. You can search them. That's what the index of methods are. You can insert information or data into there. So we can go ahead and try that. Let's create a string buffer here. Let me close this out. and I will create a string buffer of CBT nuggets, and let's insert, let me clear this out. So I'm going to say insert, and the insert method takes two arguments. The first thing is the offset. Basically, where do you want that to happen? Where do you want that new data to be appended? Okay, so I'm going to kind of do offset of 4, and we're going to append a couple of dashes. So dash, 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 several dashes rather. Oops, and let me go ahead and compile that, and we will run it, and you can see that I've inserted some dashes. So I put 4 in there. So 1, 2, 3, 4. Then I inserted all those dashes. Okay? That's what the insert method does. There's several other key methods that you can use, like reverse. So sb dot reverse, reverse, compile that, and we'll go ahead and run it. It's pretty cool. Look at that. I mean, can you imagine writing a program to go through and reverse characters in a string? That would just be kind of a nightmare if you ask me. I'd rather call the good old reverse method. In strings, we took a look at strings of character data, and we took a look at how Java works with strings. We gave you a nice definition of what a string is. Basically, each character in a string is a 16-bit Unicode character. Unicode character, which means it can store a lot of information about that character. And it can do funky characters like Japanese and Chinese and Hebrew and all cool stuff. Showed you how to create strings. There were 3 ways of creating the strings. Nice little shortcut that you can use. And we talked about that strings are immutable. Means the value can't change. And when you think it's changing, it's actually pointing to a new reference in memory. Went over some really cool methods to use with strings, like what character lives at position 4, or go ahead and concatenate using the concat method. And then I gave you an alternative to working with strings, the StringBuffer class. If you're going to be making a lot of changes to your string characters, you should go ahead and be using the StringBuffer class instead of the string class. I hope you found this informative, and I'd like to thank you for viewing.